Okay, let's give you guys some more practice. So somehow work out this area. Somehow work out this area from negative infinity to 0. So press pause and have a go. Okay, so to do this, our normal routine has always been to integrate it from b to our normal routine has always been to integrate it from b all the way to 0, from b all the way to 0, and then later on we allow b to head towards negative infinity. Later on, we will allow b to head towards negative infinity. So the first step is to integrate it from b to 0. So the first step is to integrate it from b to 0. So our next step would be to somehow integrate this. So how would we integrate this? So remember, to integrate this, we are really looking for something in such a way that when we differentiate it, it will then give us this. The thing is, if you differentiate 2 to the power of x, if you differentiate 2 to the power of x, it will give you natural log of 2 and then times 2 to the power of x. So this thing here is a constant. So we would need to somehow negate this thing here. So we would revert back to our original guess and make the adjustment. Let's make this adjustment here. Natural log of 2. So now if you differentiate this, you would get 2 to the power of x. But let me just take this one step at a time. So to integrate this, let's just consider y equals 2 to the power of x. If you differentiate this, so take the natural log of both sides, take the natural log of this, take the natural log of this x comes down here, that will then give you this, and then now you want dy by dx on its own, so times both sides by y, so that will then give you this thing here, that will then give you this thing here. So now from here, you don't want this y here, so you would revert back to here. So y, remember, y is 2 to the power of x. So you would put this into the y here. So that will then give you this. The point I'm trying to make is that when you differentiate this, you will get this thing here. So really to integrate this, you need 1 over natural log of 2 and then 2 to the power of x. So when you integrate this, it will give you this thing here. Okay, so now it's a matter of us putting this into here. So that would be 2 to the power of 0. That would be 1. This one here, and then take away, and then put a b into here. So that's 2 to the power of b, and then this thing here gets multiplied to the top. Then this natural log of 2, natural log of 2. So when you integrate it from b to 0, it will give you this thing here. But now allow b to move towards negative infinity. The minute you allow b to move towards negative infinity, you're really integrating from, you are no longer integrating from b to 0, but you're integrating from negative infinity to 0. So the minute you allow b to head towards infinity, this thing here will then become this thing here. But then on the right hand side, you will need to take the limit. You will need to take the limit as b heads towards negative infinity of this whole thing here. But then this thing here is a constant, so this thing here doesn't contain b. We are allowing b to move towards negative infinity. Here you've got one block taking away this block here. This block here is a constant. It doesn't contain b. So let's not take the limit. Let's just leave it as a constant. Now take the limit of this as b tends towards negative infinity. So take the limit as b tends towards negative infinity of this. Now, if you look at this here, bear with me. If you look at this here, 2 to the power of x looks like this. As b heads towards negative infinity, this thing here will head towards 0. This thing here will head towards 0. So you're going to get 0 divided by a constant. So this thing here is going to be 0. The whole thing here will be 0 as b heads towards negative infinity. So this whole thing here being 0. So really the area is this constant here, 1 over natural log of 2. So this area here is 1 over natural log of 2. This whole area here is this thing here. Okay.